morning, everyone. We are Group 7. Today we are presenting our study comparative analysis of visual reaction time between domain and non-domain hand. Our main research question was simple. Does your domain hand react significantly fast to visual stimuli than your non-dominant hand? To test this, we measured the visual reflex efficiency of 50 undergraduate students from NTUT using the Realme.com platform. A key strength of our study is the strict experimental control. To ensure high data reliability, we use identical lot paths and mice for everyone. We even use a rule to ensure a standardized 50 cm physical distance for the mouse alignment. This alignment hardware are a mechanical basis allowing us to capture poor sensory motor reaction times. Now speak to will share our descriptive data.
Let's move on to our descriptive summary. After collecting data from our 15 participants, we calculate the average reaction time for both conditions. Interestingly, the results were extremely close. The mean reaction time for the dominant hand was 242.94 milliseconds, while the non-dominant hand recorded an average of 243.98 milliseconds. The result in a marginal mean pair difference of just 1.04 milliseconds. As you can see from our bar chart, this baseline discrepancy is almost unnoticeable. However, human reaction times have high within subject standard deviations, meaning people perform very differently based on their daily habits or fatigue level. Therefore, we couldn't just rely on averages. We needed robust statistical testing to see if this 1.04 millisecond gap was real, which Speaker 3 will explain next. Thank you.
To evaluate our data mathematically, we apply a pair sample t-test with an alpha level of 0.05. We specifically choose a pair design because each participant tests both hands, which effectively eliminates inter-participant biological noise. Our analysis yield a t-statistic of 0.236 and a p-value greater than 0.05. Therefore, we refer to reject the non-pathologies. Furthermore, our 95% confidence interval for the difference spans from negative 7.82 to positive 9.90 milliseconds. Because this interval contains zero, it confirms the rather tiny 1.04 millisecond gap for entirely within the realm of chance variation. Statistically speaking, no significant hand dominance effect was found in this experiment.
Finally, let's discuss our eliminations and the overall conclusions. Methodologically, our main elimination was the sequential practice effects. Because participants perform consecutive trials, they might have adapted to the test format, which could slightly skew the later results. In conclusion, while the dominant hand was technically 1 millisecond faster, this mini gap is statistically insignificant. This actually aligns with neural muscle theory. While daily repetitive use reinforces complex motor control in the dominant hand, for pure immediate sensory reflex arcs like clicking the mouse in milliseconds, a screen turns green. Limb dominance is only a mirror contributor rather than a disease factor. This concludes our presentation. Thank you for listening, and we are now open to any questions.